Hi everybody. We're going to be talking about the properties of the Earth's interior part of the Earth now, and this will lead us into a discussion of earthquakes and how we know about the inside of the Earth. And as you remember, maybe from the first day, that I said that we couldn't actually dig down into the Earth more than the deepest we've ever been is about 6 miles out in Russia, and so how is it that we even know what the Earth is like? And we'll start looking at earthquakes, and earthquakes will sort of lead us into this understanding of how we know what the Earth is made out of. But these are sort of clues. We'll get into the clues as to where these layers come from. But let's just jump into it. Let's start. So the outermost layer of the Earth is called the lithosphere, and it's the solidmost part of the Earth. It includes the crust and the upper part of the mantle. So I'll sort of show you that on a diagram that you have in your reference table. And the nice part about the reference table is that it does have a diagram with these layers in it. So you don't have to memorize the layers. They're on the reference table. So that's good. You just need to sort of have an idea of where they are and what their importance is. So when we look at just the crust, it's the solid shell that floats on top of what's called the asthenosphere. And the asthenosphere is uh, the semi sort of plasticky portion of the mantle, the upper part of the mantle. So the lithosphere includes the crust and part of the asthenosphere and mantle. So there's if you turn to page 10 in your reference table, you'll see this. And you can see here's the lithosphere. It includes the crust and the rigid mantle, and the asthenosphere is directly underneath that. So there's part of the mantle above the asthenosphere that's more solid, and the crust, we call that the lithosphere. And when we talk about the lithospheric plates later on in the unit, that's what we'll be referring to. The asthenosphere is sort of like this rock that is not quite a liquid, not quite a solid. It's sort of a plasticky rock. It's able to flow, and we'll see the importance of that when we get into plate tectonics and how density plays a role in this. This includes the crust includes part of the ocean floor. It's the rock that floats on top of the asthenosphere, which is this plastic mantle. It's made of partially melted and in some places melted rock, molten material. That is an important, really important part of the overall structure of the inside of the Earth, because it allows us to have earthquakes and volcanoes, and it helps to create a lot of the geologic features that are important to us as humans and to the planet in general. The stiffer mantle is so as we're going down this list, we're going deeper into the Earth. So the area that's located between the outer core and the asthenosphere. It's a sort of a amalgam of rock that is in that area. The outer core is the liquid, and it flows around the inner core, creating our magnetic field. So the magnetic field, somebody did do an article on on a solar flare and a solar storm that created a bright aurora borealis, so the northern lights. And the Earth's magnetic field actually protects us from lots of charged particles coming from the sun. So the sun has lots of radiation, including lots of really highly energized particles. And as they hit our magnetic field, they're directed towards the poles, and they're sort of funneled away from the Earth. The magnetic field is sort of protecting us from lots of those charged particles. And so this magnetic field is created by this flowing, moving, liquid outer core, which is really important in terms of protecting us, the Earth. Okay, the inner core is solid. It's made mostly of iron-rich rock, and as well as the outer core has is iron as well. But when we sort of look at this, we can see there's iron and nickel in both the outer core and the inner core. It's labeled, oops, sorry about that. It's labeled right here in the center there. So if you go back to your bottom page here, you'll see a diagram that has sort of the layers on it. See if you can take a second and put that together. Write down the labels. Write down the labels for each of the layers. And it's good to start from the center. That's the easiest way, I think. But we can go from the center on out. And if we do that, you'll see the inner core, outer core, the stiffer mantle, asthenosphere, and then the crust sitting on top of that. And if we look at this, you can see that the area where we are is very, very thin. This outer crust is a really thin layer. Sits on top of this other thin layer, and then most of the Earth is mantle and the core. So when we slice this up, it looks sort of like that layered onion. It has that layered onion look. Now, what I want you to see here, the reason I'm sliding these over here, is because if I were to take that picture of the Earth and I were to cover up and hide part of it, you'll see that I have just sort of like a slice of a pie, uh, a portion of the Earth. And this section, as I do that, this section right here, is what you'll see on the reference table. You can see it right here. Here's that section of the Earth from the outside going down into the center and into the center this way. So if you flip your notes over, we're going to use this to help. This chart will be very helpful in helping us to learn a lot about the different parts of the Earth. So the Earth's interior is inferred. When we say inferred, we mean an inference by earthquake waves. So earthquakes allow us to learn a lot about what's going on inside the Earth, and we can see this on page 10 of the ESRT. And if you look at the top of the Earth Science Reference Table, top right of the Earth Science Reference Table, you'll see the density and composition. The composition's not in there, but I'll give you those. The composition of the continent is a type of rock called granite, and the oceans are made out of something called basalt. And if you look, the values for those are on the reference table, so that I'll have you fill in if you look at the reference table. And there's this region just underneath the crust that is called the Moho region. And it's kind of an uneven boundary between the Earth's crust and the upper mantle. And this Moho was named after a guy named Mohorovichy. He was a Russian scientist who studied earthquake waves and noticed there was this bouncing of the earthquake waves as they went down into the earth. As the waves sort of went down into the earth, they either slowed down or were reflected at a certain depth and bounced back up, and they were felt again at some of those seismic stations. And this layer that he found is the reason they bounce off of that layer and why they change their speed as they go through that layer is because there's a boundary there, and the rocks actually change. And if we look at the rocks themselves, we can see a big change in the densities. So rocks from the continents are about 2.7. The granite continental crusts is about 2.7, and once it hits this mantle, the asthenosphere is just the upper part of the mantle, it changes dramatically from a 3.4 to 5.6. And that big change in density actually causes the earthquake waves to change. So that's how we were able to know that. So one thing that I'll have you notice here is that as we go down into the center of the Earth, sorry about that, as we go down into the center of the Earth, we get a change in the density. And we'll talk about that in class, why that happens. But I want you to think about why that might be. Why is it at the center there's there's the most dense things, and up towards the surface, there's less dense things. So that's all for Earth's interior. Bring these into class, and I'll answer any questions that you might have, and we'll finish the rest of those notes in class.